LEED, which stands for Leadership in Energy and Environmental Design, is a green building certification program promoting environmentally sustainable construction practices. For electrical systems, LEED places emphasis on several key areas. Firstly, energy efficiency, which involves installing highly efficient lighting, appliances, and heating, ventilation, and air conditioning, or HVAC equipment to reduce electricity consumption. Secondly, renewable energy, which means incorporating solar panels, wind turbines, or other renewable energy sources to generate electricity. Thirdly, water conservation. This entails using fixtures and appliances that minimize water usage, such as low-flow faucets and dual-flush toilets. Fourthly, indoor air quality, which requires installing ventilation systems that provide adequate fresh air and remove pollutants. Fifthly, materials and waste reduction, specifically specifying materials with low environmental impact and reducing waste during construction and demolition. While not mandatory, obtaining LEED certification for electrical contractors can demonstrate their commitment to green building practices and provide a competitive advantage. There are two main LEED certification options for electrical contractors. The first is LEED Accredited Professional, or LEED App, which focuses on the general knowledge and implementation of LEED principles. The second is LEED Green Associate, or LEED GA, providing a basic understanding of LEED and its application. There are several benefits to LEED certification for electrical contractors, including improved public perception and reputation, increased opportunities for green building projects, enhanced technical knowledge and expertise, reduced environmental impact and operating costs, and alignment with industry best practices and regulations. To implement LEED electrical practices, there are several steps to consider. Firstly, review the LEED reference guide to familiarize yourself with the specific electrical requirements for LEED certification. Secondly, collaborate with the project team. Coordinate with architects, engineers, and other stakeholders to ensure compliance. Thirdly, specify energy-efficient equipment. Choose lighting fixtures, appliances, and heating, ventilation, and air conditioning, or HVAC, systems with high energy efficiency ratings. Fourthly, incorporate renewable energy. Explore options for solar panels, wind turbines, or other renewable energy sources. Fifthly, optimize indoor air quality. Install ventilation systems that meet LEED requirements and improve indoor air quality. Sixthly, reduce waste. Implement measures to minimize waste during construction and demolition, such as using recycled materials and proper waste management practices. Finally, it is important to document and verify all steps. Maintain records and documentation to demonstrate compliance with LEED requirements. Electrical design within the LEED framework demands careful consideration of several interconnected elements. Energy efficiency stands as a cornerstone, pushing for the adoption of lighting systems, appliances, and heating, ventilation, and air conditioning, or HVAC, equipment that minimize electricity consumption. This often involves conducting thorough energy audits to pinpoint areas of excessive energy use and implementing strategies to curb these inefficiencies. Renewable energy integration marks another crucial element, advocating for the incorporation of on-site renewable energy sources like solar photovoltaic or PV systems or wind turbines to offset grid-supplied electricity. The selection and sizing of these systems must align with the building's energy demands and available renewable resources. Water conservation, although seemingly tangential, plays a significant role in electrical design, particularly concerning water heating systems and appliances. Opting for high-efficiency water heaters and water-saving fixtures reduces both water and energy consumption. Indoor air quality emerges as a critical factor, emphasizing the design of ventilation systems that ensure adequate fresh air circulation while minimizing the influx of pollutants. This may entail employing air filtration systems, demand control ventilation strategies, and careful selection of low-emitting materials. Materials and waste reduction targets minimizing the environmental footprint of electrical materials and construction practices. This includes sourcing materials with recycled content, designing systems that minimize waste generation, and implementing effective waste management strategies during construction and demolition. To successfully integrate these elements into electrical design for LEED projects, a comprehensive approach is essential. This starts with a thorough understanding of the LEED rating system and its specific requirements for electrical systems. Collaborating closely with the project team, including architects, engineers, and contractors, ensures that electrical design aligns seamlessly with the overall building design and sustainability goals. Conducting detailed energy modeling simulations allows for evaluating the energy performance of various design options and identifying optimal solutions for minimizing energy consumption. Selecting energy-efficient equipment that meets or exceeds LEED standards is crucial, often involving a careful evaluation of product certifications and performance data. Integrating renewable energy sources such as solar photovoltaic or PV systems or wind turbines necessitates a detailed assessment of site conditions, energy demands, and available incentives. Designing ventilation systems that comply with LEED requirements for indoor air quality requires a thorough understanding of ventilation principles, filtration technologies, and material selection. Implementing waste management strategies during construction and demolition involves careful planning, material handling, and waste diversion techniques to minimize environmental impact. Documenting all design decisions, equipment selections, and construction practices meticulously is essential for demonstrating compliance with LEED requirements and achieving certification. Furthermore, staying abreast of the latest advancements in electrical technologies and LEED requirements is vital for continuously improving the sustainability of electrical designs. This includes participating in professional development activities, attending industry conferences, and engaging with relevant research and publications. LEED certification for electrical contractors offers a pathway to demonstrate expertise and commitment to sustainable building practices. While not always mandatory, holding a LEED credential can significantly enhance a contractor's credibility and competitiveness in the growing green building market. Two primary LEED credentials cater to electrical contractors. The first, LEED Green Associate, or LEED GAR, serves as an entry-level credential, signifying a foundational understanding of green building principles and LEED concepts. Attaining this credential involves passing an examination that covers various aspects of sustainable design and construction. The second, LEED Accredited Professional, or LEED App, represents a more advanced credential, demonstrating in-depth knowledge and expertise in a specific LEED rating system, such as building design and construction, or BD+C, or interior design and construction, or ID+C. Achieving this credential requires passing a more rigorous examination and demonstrating experience on LEED projects. The benefits of LEED certification for electrical contractors extend beyond mere marketing advantages. Certification equips contractors with the knowledge and skills to effectively integrate sustainable practices into their projects, leading to improved energy efficiency, reduced environmental impact, and enhanced building performance. Certified contractors gain a competitive edge by being able to offer specialized services and expertise that align with the growing demand for green building solutions. LEED certification demonstrates a contractor's commitment to sustainability, enhancing their reputation and credibility among clients, partners, and the community. The certification process fosters continuous learning and professional development, ensuring that contractors stay up to date with the latest advancements in green building technologies and practices. LEED certified contractors are better positioned to navigate the complexities of LEED projects, ensuring compliance with requirements and maximizing the potential for achieving certification. Pursuing LEED certification involves a strategic approach that encompasses education, preparation, and examination. Firstly, gaining a thorough understanding of the LEED rating system and its specific requirements is crucial. This involves studying the LEED reference guide, attending workshops or training courses, and engaging with online resources. Secondly, assessing existing knowledge and experience in green building practices helps identify areas where further learning or development is needed. This may involve taking practice exams, seeking mentorship from experienced professionals, or participating in relevant projects. Thirdly, preparing for the LEED examination requires a dedicated study plan and consistent effort. This includes reviewing the LEED reference guide, practicing with sample questions, and familiarizing oneself with the examination format. Fourthly, scheduling and taking the LEED examination is the final step in the certification process. This involves registering for the exam, selecting a convenient testing location and time, and arriving prepared and confident. Fifthly, maintaining LEED certification requires ongoing professional development and adherence to ethical standards. This involves earning continuing education credits, participating in industry events, and upholding the principles of sustainability in professional practice. Implementing LEED electrical practices demands a systematic approach that integrates sustainable principles into every stage of the project lifecycle. A crucial first step is reviewing the LEED reference guide to gain a thorough understanding of the specific electrical requirements for LEED certification. This involves familiarizing oneself with the various credit categories, performance metrics, and documentation requirements. Collaboration with the project team, including architects, engineers, and other stakeholders, is essential to ensure seamless integration of electrical systems with the overall building design and sustainability goals. This involves participating in design charrettes, providing input on material selection, and coordinating with other trades to avoid conflicts or inefficiencies. Specifying energy-efficient equipment is a critical aspect of LEED electrical practices. This involves selecting lighting fixtures, appliances, and heating, ventilation, and air conditioning, or HVAC, systems that meet or exceed LEED standards for energy performance. Incorporating renewable energy sources, such as solar photovoltaic, or PV systems or wind turbines, can significantly contribute to LEED points. This involves evaluating the feasibility of on-site renewable energy generation, assessing site conditions, and selecting appropriate technologies. Optimizing indoor air quality is a key aspect of LEED electrical practices, involving the design and installation of ventilation systems that provide adequate fresh air and minimize the influx of pollutants. This may involve employing air filtration systems, demand control ventilation strategies, and careful selection of low-emitting materials. Reducing waste during construction and demolition is another important element of LEED electrical practices. This involves implementing measures to minimize waste generation, such as using recycled materials, designing systems that minimize cutoffs, and implementing effective waste management strategies. Documenting all design decisions, equipment selections, and construction practices meticulously is essential for demonstrating compliance with LEED requirements and achieving certification. This involves maintaining detailed records of energy performance, material specifications, and waste management practices. LEED's emphasis on energy efficiency in electrical systems is particularly relevant. This extends beyond simply using energy-efficient equipment. It involves a holistic approach to electrical design that considers the entire building's energy consumption. One key strategy is to optimize lighting design. This involves using energy-efficient lighting fixtures such as light-emitting diodes, or LEDs, and compact fluorescent lamps, or CFLs, and incorporating daylighting strategies to reduce the need for artificial lighting. Lighting controls, such as occupancy sensors and dimming systems, can further reduce energy consumption by automatically adjusting lighting levels based on occupancy and ambient light levels. Another important aspect of energy-efficient electrical design is to minimize electrical losses in the distribution system. This can be achieved by using appropriately sized conductors, minimizing voltage drop, and reducing harmonic distortion. Energy-efficient transformers and power distribution units can also help to reduce electrical losses. LEED also encourages the use of advanced metering systems to monitor and track energy consumption. These systems provide valuable data that can be used to identify areas of energy waste and optimize energy performance. Renewable energy integration is a significant component of LEED's approach to sustainable electrical systems. Solar photovoltaic, or PV, systems are a popular choice for generating on-site renewable energy. These systems convert sunlight directly into electricity, reducing the reliance on grid-supplied power. The size and orientation of the solar photovoltaic, or PV, system should be carefully considered to maximize energy production. Wind turbines are another option for generating renewable energy, particularly in areas with consistent wind resources. The placement of wind turbines should be carefully evaluated to minimize noise and visual impacts. LEED also recognizes other forms of renewable energy, such as geothermal and biomass. The choice of renewable energy source will depend on site-specific conditions and resource availability. Water conservation measures can also have a significant impact on electrical systems. For example, using high-efficiency water heaters and water-saving fixtures can reduce the amount of energy needed to heat water. The selection of appliances should also consider water and energy efficiency. For example, Energy Star certified appliances meet stringent standards for both water and energy consumption. Indoor air quality is an important consideration in LEED electrical design. Proper ventilation is essential to ensure that indoor air is free of pollutants. Ventilation systems should be designed to provide adequate fresh air while minimizing energy consumption. Air filtration systems can remove pollutants from the air, improving indoor air quality. The selection of electrical materials can also impact indoor air quality. Low-emitting materials should be used to minimize the release of volatile organic compounds, or VOCs, into the air. LEED promotes materials and waste reduction in electrical systems. This includes using materials with recycled content and minimizing waste during construction and demolition. Recycling electrical materials such as copper wire and aluminum conduit can reduce the environmental impact of electrical systems. Construction waste management plans should be implemented to minimize the amount of waste that is sent to landfills. Effective documentation and verification are essential for achieving LEED certification. This includes maintaining detailed records of energy performance, material specifications, and waste management practices. Building commissioning is an important process that ensures that the electrical system is operating as designed and meeting LEED requirements. The commissioning process should include testing and verification of all electrical equipment and systems. It's important to remember that the specific requirements for LEED certification can vary depending on the project type and rating system. The LEED reference guide provides detailed information on the requirements for each credit category. Consulting with a LEED accredited professional or LEED app can help to ensure that the project meets the requirements for certification. The ultimate goal of LEED electrical design is to create sustainable buildings that minimize environmental impact, reduce energy consumption, and improve indoor environmental quality. By following the principles and practices outlined in the LEED rating system, electrical contractors can play a vital role in creating a more sustainable built environment.